How to find the number of unique paths with obstacles. Problem statement. The input would be n, which is the dimensions of a matrix, and an obstacle map. The 0 means that there's no obstacles on the map, and the 1 means that there is. The rule is that you can only go right or down on each cell of the matrix. The output would be the number of unique paths from the top left corner to the bottom right. So, example 1. Since there are no obstacles, there are two ways to get from the number 1 to 4, which would be 1, 2, 4 and 1, 3, 4. Example 2. Since there's an obstacle that's in the corresponding place of 3, you can't go to 3. So there's one way to get from 1 to 4, which would be 1, 2, 4. Observation 1. Since we can only go right or down, there's only one way to reach the first row and column. So we fill up the dynamic programming table with 1 for the first row and column. If there is an obstacle, the rest of the cells will be 0. So it would be like this. There's an obstacle here, so all of these cells have to be 0. Observation 2. For each cell other than the first row and column on the dynamic programming table, if there's an obstacle in the obstacle path, it would be 0. So the example would be 1, 1 right here is 0. Observation 3. For the cells other than the first row and column on the dynamic programming table, if there's no obstacle, then it would be the dynamic programming tables 2, I and j would be, you get the number of unique paths from the corresponding top value and the corresponding side value on the left side, and you get the sum of that. So for this one, you look here. So you look at the left side, and it's 1. Then you look at the top, and it's 1. So this is 0, this is 1. 0 plus 1 is 1. So it would be 1. Code illustration. So first we make a dynamic programming table that has the dimensions of n. And then you go through each element on the thing, and if there's no, and so first you go through the first row. You go through each cell, and since there's no obstacles, every one of them is 1. And now you look at the side. You fill, and then since this has a 1, has an obstacle, the rest of it would be, you break, and this will stay 0. And now you're looking here. Since there's an obstacle, then you don't do anything and it stays 0. And then when you look here, since there is not an obstacle, you add the 0 and the 1, which will make 1. Here, 0 plus 0 is 0, so this will stay 0. And here, 0 plus 1 is 1, so it would be 1. The output, this function will return 1, because there's one unique way to get from here to here, and that would be from going here, 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 here. And so it will return 1. Thank you for watching.